Okay, over here question is the major products X and Y formed in the following reaction. We have to find out. So over here we can see that the H is lying opposite to the Br. So that means if elimination takes place via a E2 process, okay, the ene that will be formed by a concerted step is going to have the geometry as follows. Okay, so this will be the structure of product X. And out here, as we can see in this, the hydrogen is in the same direction. So we have to rotate this bond, and that means what will happen? The pH goes over here, and the Br goes over here. The Me is over here. The H is over here. So if we take this one, then that will be released. Okay, so that means our product over here will be something like that. And hence the correct option over here is going to be B. Which of the following is true for the reaction given? So out here we have to draw the chair conformation like that we draw. Suppose this is the Cl, the Me obviously is like this, and the isopropyl group also is like that in the equatorial bond, and over here the Me is in the axial bond. Okay, now we are treating this with OMe. So the in elimination from this carbon cannot take place because for that anti positioning of the hydrogen is required. So here only we are having the hydrogen anti in this bond, that is from this carbon. So the base will take from here, that means the chlorine will grow from here, that means there is a double bond over here formation. So that being the case, we will say our product over here X will be option B. Which one of the following statements are true about the kinetics of a E1 reaction of an alkyl halide in presence of a base? So for rate of E1 reaction, we will say it is just depend on the Rx. Okay, elimination unimolecular, right? So rate of the reaction doubles by doubling the concentration of the alkyl halide, which is true. Rate of the E1 reaction doubles by doubling the concentration of the base, does not depend on the base. Rate of the reaction decreases by changing the alkyl halide from this to this. Yeah, elimination is possible better in a crowded carbon. So this is a 3-degree carbon, more crowding, more elimination. So if you go to this one, then rate will be decreasing. So this is also true. Rate of elimination increases from changing the solvent from, obviously this is elimination unimolecular, that means it forms the carbocation. So if you use a polar protein medium, rate will be increasing. Okay. So that means over here options 1, 3, 4 will be correct option. IUPAC names of the following substrate X and the product Y formed in the reaction are as follows. We have to find out. So over here, First of all, we have to find out what is this. So it is basically, we have to name from here. 1, this is carbon 2, so this is 3, okay, like that. So this is basically 2,3-dibromopentane, no doubt about that. But what is this absolute configuration of this carbon and that carbon? Hydrogen, when it is on the horizontal bond, whatever you get absolute configuration, it is just the reverse. So this is 1, this carbon is 2, and that is 3. So we are going like this. Okay. So what will we say? Going anti-clockwise, right? So this is going to be 2R. This one, 2R. What about this one? 1, below carbon is 2, and that one is 3. So over here we're going like that, clockwise. So we have to take the reverse. What is that? We will say for this one it is 3s. So 2R, 3s, that is first of all we have to understand. So over here this one and that one is incorrect. So you have to choose between A and B. Okay. Next thing is what? We have to write this molecule in such a way. So this is basically what we have in the structure. We are writing the Shawhorse from Fisher. Okay. So that is what we do. CH3H, and that is ET. Sorry, ET is below, and that is H. So we rotate it in such a way that this Br and that Br becomes anti to each other. Okay. So that means what we do is, if we go like that, then this goes obviously in this direction. Okay. ET comes over here, right? And H comes here, right? And Br goes here. This Br is here, and that H is here, and CH3 is here. Okay, we can think like this also. So now iodine will do what? It will attack here, this will go here, and that will go out. Okay, so instead of doing this way, let's do it in a more standard way. We take the Br down. Okay, so we take the Br down like this. If I take the Br down, my CH3 or Me goes over here, and my hydrogen comes over here. Okay, so this is how it is. And then I take the Br up, so that means my hydrogen comes here and my Et goes here. So that is how we have done. Now with iodine we will do this. So over here we are getting basically a Et over here, H over here, Me over here, and H over here. So this is a E type of a pentene. So answer will be obviously A.